Now let's look at the derivative of tan inverse. Using implicit differentiation, again, we get that the derivative with respect to x of tan inverse of x is 1 over x squared plus 1 for every x value between minus infinity and infinity. And of course, to differentiate something like tan inverse of the natural log of x, we can use this formula along with the chain rule. So first of all, let's look at the domain of this function, tan inverse the natural log of x. We know that the domain of the natural log of x is restricted to positive values between 0 and infinity, but after that tan inverse can be applied to anything, so that's the only restriction on the domain here. So the domain of this function is everything from 0 to infinity. And now its derivative we can calculate using the chain rule. So it's the derivative of tan inverse with respect to the natural log of x, which is 1 over 1 plus the natural log of x squared, times the derivative of the natural log of x, which is 1 over x. So tidying up a little bit, we get the derivative of our function is 1 over x times 1 plus the natural log of x squared. Finally, let's look at some integration formulas. So if we reverse our two formulas for derivatives above, we get that the integral or the antiderivative of 1 over the square root of 1 minus x squared is sine inverse x plus a constant. And the integral of 1 over x squared plus 1 dx is tan inverse of x plus a constant. So suppose I want to integrate the function 1 over 1 plus 4x squared from 0 to 1/2. Now this looks similar to the integration formula for tan inverse, so I would like to reshape this to the form 1 over 1 plus u squared using a substitution. And a fairly obvious substitution to try is if I let u equal 2x, then certainly the integrand will look more like 1 over 1 plus u squared. Du in this case is 2 times dx because du dx is 2, and applying the function u to the endpoints, I get u of 0 is 0 and u of 1/2 is 1. So now making the substitution, we get that our original integral is 1/2 1 over 1 plus u squared du, because dx is du over 2. The integral runs from 0 to 1. So now, of course, the integral of 1 over 1 plus u squared du, according to our formula, we've just changed the x's to u's, is tan inverse of u. And our integral is 1/2 tan inverse of u evaluated between 0 and 1. So it's 1/2 tan inverse of 1 minus tan inverse of 0. And of course I have to find the unique angle between minus pi over 2 and pi over 2, where the tangent of that angle is 1 to evaluate tan inverse of 1, and that should be pi over 4. And the unique angle between minus pi over 2 and pi over 2 with tangent of theta equal to 0 is theta equal to 0. So that gives me tan inverse of 0 is 0. My final answer is 1/2 pi over 4 minus 0, which is pi over 8. Now this integral, our second example, looks similar to the integral in the formula for sine inverse, so we should try to find a substitution which reshapes it into the integral of 1 over the square root of 1 minus u squared. Well, we should perhaps take the 9 out from under the square root sign. 9 minus x squared is 9 times 1 minus x squared over 9. And then when we pull the 9 out from under the square root sign, it becomes a 3. So we can reshape our integral as 1 over 3 times the integral of 1 over the square root of 1 minus x squared over 9. And now this looks more like 1 over the square root of 1 minus u squared, And if we let u equal x over 3, that should do the trick. So letting u equal x over 3, we have dx is equal to 3 times du, so we can substitute 3 times du for dx, and we don't have, it's not a definite integral here, so we don't have to convert endpoints. So our integral becomes 1 over 3 times the integral of 3 times du over the square root of 1 minus u squared. And of course, that's 3 over 3, which is 1 times the integral of 1 over the square root of 1 minus u squared du, which is sine inverse of u plus c. And now, of course, because we were asked to calculate an integral in x, it's polite to give the answer back in terms of x, so converting sine inverse of u to a formula in x's, we have u equals x over 3, so it's sine inverse x over 3 plus a constant.